Okay, we've been looking at probability of basically some random variable x. And that random variable x could either be a discrete variable or a continuous variable. And so, for example, a discrete variable might be out of the next 10 planes, how many will be delayed. We could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or all 10 planes delayed. So there's 11 possibilities, and they're countable possibilities for the number of planes to be delayed out of the next 10 planes. So when I think of discrete, I think of countable. And I also think of, it doesn't necessarily have to start at 0, but if I were to make a number line for this, I would have a number of discrete points on that number line. Not so with continuous. Continuous is not countable. So for example, time would not be countable. So it may be x is, I randomly select a student and time how long it takes for them to take a quiz, and it could take anywhere between 0 and 60 minutes. There's not a countable number of time between 0 and 60 minutes. It's basically you could have taken 15 minutes, or 15.5, or 15.75, or 15.0555, etc. So between any 2 points for continuous variable, there's an infinite number of values. That's for continuous. Okay, so why do I start out with talking about discrete and continuous? Because we are going to look at probability distributions. And so just to sort of look ahead, if you have a continuous random variable and you are looking at the probability distribution, we might be looking at, say, for example, height in inches. So that's continuous variable, height in inches. And we could have the heights of men in the United States are normally distributed, and the mean height, I don't know, let's say what's 69 inches is, I guess that's only 5'9", but I'm just making it up, doesn't matter. So we would have x, here's the probability that you would be between, some certain values, some certain heights, and we would write the probability of x up here. For a discrete random variable, as I said before, we might have x be the number of late planes. Instead of 10, let me make it a little shorter. Out of the next 4 planes, what's the probability that 0 are late? I don't know, let's say that's 15%. The probability that 1's late, that's maybe, 25%. 2 are late, well, that's maybe 10%, and then we have 2 more possibilities. 0 are late, 1's late, 2's late, 3's late, or 4 are late. And the probabilities of any one of these have to add up to 1. Because this is a probability distribution, and these are all the possibilities, and so the probabilities must add up to 1. So I'm going to go ahead, since I made up these numbers, this is 15 plus 25, that's 40, plus 10, that's 50. So these must add up to 50%. In other words, they all have to add up to 1. All probabilities, and I think you guys probably know this by now, that all probabilities must be between 0 and 1, and that the sum of the probabilities within a probability distribution, the sum of the probabilities must equal 1. When we're looking at a discrete random variable x and we're looking at the probability distribution, we can determine what is the expected number of late planes out of the next 4. And the expected number we write sometimes as either the mean, e of x, or mu, which is, again, the expected number of late planes out of the next 4 planes. How do I do that? Well, this is the sum of x times p of x. Okay, so mu, or expected value, is equal to the sum of x times p of x. Let's go ahead and figure out what the mean, or expected number of late planes out of the next 4 will be. Let's see, x times p of x here. This is 0 times 0.15, or 0. 1 times 0.25, 0.25, 2 times 0.10, 0.20, and 3 times 0.30. Last but not least, we have 4 times 0.20, and we get 0.80. All right, so we just did x times p of x. Now we're going to take the sum of all of those, which means that we're going to add up all of these. So we've got 0.25, 0.45, 1.35, let's see, 1.35 and 0.80 will give us 2.15. So out of the next 4 planes, we expect 2.5 to be late, or to be delayed. I think we said it the same thing, right? But we expect 2.15. That is the mean. All right, so I'm going to write the mean as 2.15 up here, or the expected value. Another thing that you have in your homework is the standard deviation. And the standard deviation is the square root of the sum of the squared deviations. In other words, take x, subtract the mean, square it, and then multiply it times the probability of x. Do that for as many x's as we have, x minus the mean squared times probability of x minus the mean squared. In this case, 5 times. Add them all up, and then take the square root, and this will be your standard deviation for the expected number of planes here, the number of planes that will be late of the next 4 planes. Okay, so how do we do this? Well, we know that the mean is 2.15. So I am going to take x minus the mean. I'm going to do that first, then I'm going to square it, and then I'll multiply it by the probability of x. So in other words, we have 0 minus 2.15, or negative 2.15. 1 minus 2.15, or negative 1.15. Again, bear with me, I'm going to pause this and subtract the mean from x 5 times. All right, you'll notice I took x minus the mean, and I subtracted the mean from x 5 times. I got negative 2.15, negative 1.15, etc. The next step, if we look at our standard deviation, so basically I did this step. Now I want to square those values. Okay, so I take negative 2.15 and I square it. Same thing for negative 1.15. By the way, whenever you square any value, it's going to be positive. So here we have negative values, here we have positive values. You're always going to get a positive value when you square it. So watch out, if you get a negative value, make sure just to drop that negative, because it's going to be the same thing squared. If it were negative 2.15 squared or positive 2.15 squared, you'd still get 4.6225. All right, so now I've done the squared deviations. Next step is to multiply it times the probability. So in other words, I'm going to do 0.15 times 4.6225. So let me pause that for a moment, and I'm going to basically expand it out and multiply the probability times the squared deviation. Alright, so I ran out of space on my huge table here, but basically I did the following. I took the probability of x times the squared deviation, and I got, well, the squared deviation times the probability of x. And I did this again 5 times. 0.25 times 1.3225 equals this, etc. This times this squared deviation gives me this. Okay, so after that, I look at my formula. I have now done the squared deviations times the probability of x. The next step is to take the sum of those probabilities. In other words, sum of the squared deviation times the probabilities. So I'm going to add all of these up. When I add them up, I get 1.927525. All right, that's basically everything that was underneath my square root. And my last step, so that was the variance, my last step is to take the square root of the variance, in other words, to get the standard deviation. And if I take the square root of the variance and get the standard deviation, it's 1.388. Let's call it 1.39. All right, so that is the standard deviation for a discrete random variable. So tedious, but not too difficult. You just saw the video on a discrete random variable x for a probability distribution. You could have more than one outcome for x. 0 through 4, 0 through 5, etc., and some probabilities which add to 1. All right, we found out the mean is the same thing as the expected value, which is simply the sum of x times p of x. And the standard deviation is the square root of the sum of the squared deviations times the probability of x. Next, we will see another discrete random variable x, but we will be looking at a binomial distribution. So that would be the next video to watch.